Welcome to the Mycotoxin Prediction forecast brought to you by Biomin, the world leader in mycotoxin management. This week, we will look into the predicted risk for mycotoxin contaminations in European maize. Wet weather and high humidity are critical for infection with toxin-producing fungi during flowering time and continue to be critical for the accumulation of mycotoxins in the crop. Our prediction model therefore uses weather in combination with the related estimated times of silking to assess the future risk of contaminations with mycotoxins. The first crops started flowering late June in the most southernest part of Europe. These countries saw at least a few days with more than 2 hours of rainfall in the 15 days period. Most rainfall occurred in inland Spain and Turkey with up to 4 or 5 days of rain, while Greece and Italy remained mostly dry. Early July was essentially dry in the south. The only exceptions were Serbia and Bosnia and Herzegovina, who received up to 4 days of rain. In contrast, heavy rainstorms started to hit Germany and surrounding regions by mid of the month. Within this period, most crops in the European maize belt have started to flower. While it remained very dry in Mediterranean countries with only a few days of rain in inland regions of the Balkan states and Italy, heavy rains and floodings continued in Central Europe, with the most rain now hitting northern Germany, Denmark and Alpine regions reaching down to the Po Delta. Eastern Europe from Bulgaria to the Ukraine remained comparably dry. In the first half of August, maize in the more western growing regions reached silking. In this period, the weather was mostly dry with 3 or 4 days of rain in France and a bit more along the coastlines reaching Denmark. Significant rain events with up to 9 days of rain persisted in Poland down to the Czech Republic. Based on the current weather forecast, the predicted risk for aflatoxins is highest for countries that experienced hot conditions favorable for growth of the fungal pathogen, in particular Italy, the Balkan states and Turkey. The average risk for harvests to contain aflatoxin concentrations higher than 2 parts per billion is given here as percentage average for major European regions, giving more weight to higher yielding areas. The highest risk is calculated for southern countries, with a predicted chance of 16% of harvests containing aflatoxin concentrations above this threshold. High concentrations of fumonisins are expected in countries with high humidity combined with higher than average temperatures. The predicted chance for harvests contaminated with 500 parts per billion fumonisins or more is highest with 46% in southern European countries. The risk for Central and Eastern European countries is estimated with 26 and 20% respectively. Deoxynivalenol also depends on rainfall, but accumulation is associated with cooler, temperate conditions. The predicted risk is therefore moderate in southern European countries with high temperatures and little to no rain, but risk is high throughout the rest of Europe with up to 77% chance to exceed the threshold level of 150 ppb. Analogous to deoxynivalenol, zearalenone is produced predominantly under cooler conditions. The predicted chance for contaminations higher than 50 ppb are highest in Central European countries and Northern European countries with 36 and 40% respectively. Keep tuned in for our European mycotoxin prediction and occurrence updates as the maize growing year unfolds.